So today you're gonna learn how to solve quadratics by graphing. So just yesterday you learned how to graph them, and today you're just learning how to solve them once you graph them. And so for this, so this first one here, so you know this is a graph of a quadratic because it's in the shape of a parabola here. And then for this first question here, this asks you to state the real roots of the quadratic equation whose related functions graphed at the right. Pretty much here, so this is asking you for the roots. And so when they call them roots, so there's a couple different names that they can have. So I'll write them. So the first one it says there would be the roots. So they could call them the roots. These are all the different names that are talking about the same thing. So they could call them roots. They can call them solutions. They could call them zeros. Or the last name that they would have for them would be x-intercepts. So these are all referring to the same thing pretty much. So this is asking you the real roots of this quadratic equation whose graphed here. Pretty much this is asking you what your x-intercepts would be. It's asking you where it crosses the x-axis. So for this quadratic here, so you know your x-axis is this one here. It's also labeled. So it crosses or touches your x-axis here and then here. So that means for this one here, you have two solutions or two roots or two zeros there. So this one here, x would be equal to -1 there. So that would be your first root or solution there. So your first would be -1. And then you can count over. So this is left 3. So your other root would be -3 then. So that would be the answer to that question then. And then sometimes you may see them represented this way. So you may see them inside brackets here. So you could see -1, comma, -3. So if you see them inside the brackets, just know that if you're representing it that way, it can't be parentheses, because if it was parentheses, it would be an order pair. Like you don't mean left 1, down 3. You mean -1 and -3. So you can write it this way with an and, or with the bracket and a comma in between. So that's what the roots would be for this quadratic that's graphed there. And then, so they could refer to it any of these 4 different ways. It's asking you for the same thing there. So pretty much for these here, we're just going to graph these equations and then just figure out where it touches or crosses your x-axis is all you're trying to figure out here. And then for these, so y'all want to always make sure that all of your terms are on the same side here. And then you can pretty much ignore the 0 here. It's kind of like y equals x squared plus 6x minus 7. You can ignore the equals 0 because you'll just want everything on the same side, and it already is there. And so for these, you'll start out by subbing in the -1, 0, and 1 like you did on the stuff yesterday. So I'm going to draw the table first. So those will be the x's you can sub in to start then. And so just make sure, remember, so when you sub the -1 in, so you'll put in parentheses before you square it because it's a negative number you're squaring there. And I'll just put it in parentheses there too, just to make it easier. Anyway, so if you square the -1 to -1 times -1 would be 1. And then 6 times -1 would be -6. So 1 plus -6 would be -5. And then -5 minus 7 will be -12 then. And then next you can sub your 0 in. So 0 squared would still be 0, 6 times 0 would still be 0, and then so 0 minus 7, so that'd be -7. And then you can sub your 1 in next. So 1 squared would be 1. 6 times 1 would be 6. So 1 plus 6 would be 7, and then 7 minus 7 would be 0 then. So I will graph these points next, and then you can see where this is headed. So -1, -12, so left 1, down 12. And then your next point, 0, -7. So that'll be here. And then 1, 0. So that'd be here. I'm going to change the color of these just so that they're easier to see. And then, so the coefficient of your x squared term is positive here. That means, remember, this is opening upwards, kind of like U-shaped instead of like an upside down U here. So this is coming down this way here. So I would sub in values to this, like to the left here, the negative numbers. Because if you sub in like 2 next, it'd be really steep up there because you know it's coming down this way. So I'd sub in the -1 next to see what we get out then. I mean -2 because you already did the -1. So you can sub in -2 next. So if you square the -2, so that'd be 4. And then 6 times -2 would be -12. So 4 minus 12 would be -8. And then -8 minus 7 would be -15 then. So then I'll graph this point. So -2, -15 would be down here. And then you still don't know if that's your vertex. Remember, once you know this coming back up, you can follow the same pattern here. We have to keep going for now until you know this is coming back up. So I'd sub in the -3 next to see what we get out. And then this will be a -3 there. So -3 squared, so that'd be +9. And then 6 times the -3 would be -18. So 9 plus -18 would be -9. And -9 minus 7 would be -16. So you can graph the -3, -16 then. So left 3 down, 16 would be down here. And then it looks like that might be your vertex, but I would sub in your -4 next to make sure that it's coming back up then. So -4 squared, so that'd be +16. And then 6 times -4 would be -24. So 16 minus 24 would be -8. And then -8 minus 7 would be -15. So -4, -15 here. So, this is going back up here because this is your vertex here because that's your lowest point here. I was going to regraph these because they look a little weird. So that was the -4, -15 there. So this parabola is coming back up here. So that means you can follow the same pattern to get the rest of your points. You don't actually have to sub in the rest. So you can count this out. So from here, this is 1, 2, 3, up 3, right 1. So you can go from this point. So up 3, out 1 then. And then you can count from here. So 1, 2, 3, 4, 5. So up 5, out 1. So your next point would be here. And then you can get your last point. So it's up to here and then out 1 from there. So that means your last point would be here. And then you can connect these then for your parabola. So your graph would look something like this then. And then for the final answer, so it just wants to know what your solutions or the root to be here. So you just want to know where it touches x-axis. So you have 2 solutions here because it touches here and then here. So here your x would equal to 1 because you're going right 1. So that means your first solution here would be 1. And then this 1, 2, 3, 4, 5, 6, 7. So that's left 7. So your first solution's 1, and then your other one's -7 there. So that would be your solutions or roots there. That's a 1. It looks weird. So it'll be 1 and -7 there. And then for the next one here, so you want to make sure all these terms are on the same side here, and so they are. You don't have to move anything first there. Remember, like the other one, you can ignore the 0. And so you'll start out like the other one by subbing in your x's of -1, 0, and 1 is what I would do to start, just to see what you have there. So you can sub your -1 in first. I'll write it out here. Just make sure it's a negative, so you put in parentheses before you square it. So when you square the -1, so the negative times a negative would be positive there. And then, so 1 minus -1 would be 2. And then 2 plus 4 would be 6 there. And then you can sub in your 0 next. So 0 squared would still be 0. And then -0 would still be 0. And then 0 plus 4 would be 4 then. And then you can sub your 1 in next. So you can do 1 squared. So 1 squared would still be 1. And then if you sub the x in for the next one, you'll have 1. So 1 minus 1 would be 0 there. And then you could do 0 plus 4. So that'd be 4 then. So you can graph these points and then see which way it's going. So -1, 6 would be here then. 0, 4 would be right here. And then 1, 4 would be here. So for this one here, so the coefficient of your x squared term is positive. That means this parabola is opening upwards like the first one you did there. Which means, this is already coming back up here. That means your vertex would be between these 2 points. It would kind of like loop down here just a little because it couldn't like bottom out. It couldn't be flat there on the bottom. But your parabola would keep coming up this way because from here you went up 2 out 1, so up 2 out 1 would be here then. So pretty much you can connect these here. Your parabola, the graph of the quadratic there would look something like that because it doesn't come back down at all. I mean, so you could sub in like 2 and -2 there, although you really wouldn't have to at all because you could already tell based on these values that it wasn't coming back down there. So this, because for your solution, it's where it crosses or touches your x-axis here. So this one doesn't touch your x-axis at all. So this would be no solution then, since it doesn't cross down here. Yeah, so that's no solution then. And then for the next one here, so this one, so you have b squared plus 4b equals -4. So this one has b's instead of x's, but it'll work the same way. You can just pretend like they're x's here. So for this one, you'll want all your terms on the same side, which means you need this 4 over here because you want a 0 there. So you should add 4 to start, which means this will cancel. If there was like 2, if it could be combined with these, it would, but you can't, so it'll just be at the end. So you'll have b squared plus 4b plus 4. So this will be your quadratic here that you can sub your values into. Okay, we'll call them x's here, even though we really have b's, but you can start with -1, 0, 1 like the others there then. So just make sure you put the negative in parentheses because they're squaring it here. So if you square the -1, so -1 times -1 would be +1 there. And then 4 times -1 would be -4. So 1 plus -4 would be -3. And then -3 plus 4 will be 1 there. And then you can sub your 0 in next. So 0 squared would still be 0. 4 times 0 would still be 0. And then 0 plus 4 would be 4. And then you can sub the 1 in next. So 1 squared would be 1. And then 4 times 1 would be 4. So 1 plus 4 plus 4 would be 9. So you can graph these. So negative 1 would be here. And then 0, 4, 1, 9. So over to 1 and then up to 9 here. And then the coefficient of your x squared term, they're b's here, but it'll be the same. It's positive. So this is going to open up like the other two we've done so far today. Which means, you know, it's coming down this way. So you don't really care what these values are going to give you because they'd be way up high there, but you'll keep going this way. So you'll sub in the negatives next. So because you stopped at negative 1, so I would try subbing in negative 2 next. Because you'll have to keep subbing in the values in that direction until you know it's coming back up there. So you can sub the negative 2 and then. So if you square the negative 2 there, so that'll be 4. And then 4 times negative 2 would be negative 8. So 4 plus negative 8 would be negative 4. And then negative 4 plus 4 would be 0 then. So you can graph this. So negative 2, 0 will be here. And then you can sub in the negative 3 next because we don't know if it's coming back up yet. So you have to try the negative 3. So if you square the negative 3 to start, so that'll give you 9. Because negative 3 times negative 3. And then 4 times negative 3 here would be negative 12. So 9 plus negative 12 will be negative 3. And then negative 3 plus 4 will be 1. So you can graph negative 3, 1. So this will be here. So that means this is coming back up here. That means instead of subbing all these values, you can follow the pattern. Because this went up 3, out 1, so you can do the same thing from here. So up 3, out 1. So that means this point down here was your vertex because it didn't go any lower there. And then you can get your other point here. So up to here and then out 1. And then, so you have all your points here. So then you can just connect them to make your, the graph of the quadratic, the parabola here. It should go through all these points. Okay, there's squiggly shouldn't be there. It's harder than it looks. For this one, okay, I think that's as good as it's gonna get on this thing. So for this one, so this wants to know where you touch the x-axis or where it crosses the x-axis. For this one, this just touches your x-axis once here. You just have this one solution here because it doesn't go any lower than that. So here is when your x is equal to negative 2 because that's left 2 from the origin there. So your only solution here would just be negative 2. There's only one root or 0 there. Just because it touches and then comes right back up. And then for the very last one here, so this says solve n squared plus 6n plus 7 equals 0 by graphing. If integral roots can be found, estimate their roots by stating the consecutive integers between which the roots lie. We're gonna graph this first, and then I can tell you what all the other stuff means here. So you can just look at this to start. So your equation, so everything's on the same side, so that's good there. And then, so pretty much you can sub in the negative 1, 0, and 1 to start, which are going for the ends there, but. So for the negative ones, just make sure you put in parentheses. So if you square the negative 1, so then you'll get positive 1. And then 6 times negative 1 would be negative 6. So 1 plus negative 6 would be negative 5. And then negative 5 plus 7 would be 2 then. So that'd be 2. And then you sub your 0 in. So 0 squared would still be 0. 6 times 0 would still be 0. So 0 plus 7. So that'd be 7 then. And then you sub the 1 in. So 1 squared would be 1. 6 times 1 will be 6. So 1 plus 6 plus 7. So that'll be 14 then. And you can graph these and see what's happening to see what to sub in next. So negative 1, 2 will be there. And then 0, 7 be there on your y-axis. And then 1, 14. So over 1 and then up 14. So now that you have these 3 points, the coefficient of your n squared or your x squared term here is 1. That means this one will be like the other. So it's going to open upwards, your parabola there, which means it's coming down this way. So you'll sub in the negatives because it's going to keep coming down this way then. So I'd sub in like negative 2 and negative 3 next until you know it's coming back up, and then you can follow the pattern there. Okay, so negative 2 next is what we're subbing in. So negative 2 squared, so that'd be positive 4. And then 6 times the negative 2 would be negative 12. So 4 plus negative 12 would be negative 8. And then negative 8 plus 7 would be negative 1 then. And then you can sub in your negative 3. So negative 3 squared would be positive 9. And then 6 times negative 3 would be negative 18. So 9 plus negative 18 would be negative 9. And then negative 9 plus 7 would be negative 2. So you can graph these. So negative 2, negative 1, so left 2, down 1 then. And then negative 3, negative 2. This will probably start coming back up, but you need to sub in the negative 4 to make sure it is here. So you'll sub in the negative 4 next, because you can't really tell for now. So negative 4 squared, so that'd be positive 16. And then 6 times negative 4 would be negative 24. So 16 plus negative 24 would be negative 8. And then negative 8 plus 7 would be negative 1 then. You can graph negative 4, negative 1. So this graph is coming back up. So that means this is your minimum. It doesn't go any lower there. So you can follow the same pattern here. So this is up 3 and then over 1. And then you can do the same thing to your next one here. Because that's up 5 and then out 1. And then up to there and then out 1. So these will be all of your points there. And then you can connect your points here. Now that you have all of them. So you can draw your parabola, the graph of your quadratic. That was good until I got there. I'm trying to show you where it's going to cross because that matters. Okay, this squiggly line shouldn't be there, but we don't care about that right now anyway. It should be a straight line because you just care where it crosses your x-axis here. So for the solutions here, this one's a little different from the others because you have a solution here and then you have a solution here. These aren't at a whole number because it's between two numbers here. So for this one, so this is what it means here. So you're just saying which two numbers this is between. Because so we like by graphing, so you can estimate it, but you don't know exactly what number it is. For this one though, since this is 0, -1, -2, this will be between -1 and -2 on your x-axis for the first solution for this dot here. So that'd be between -1 and -2 then. Later on, you're going to learn other methods you can use to solve, but for graphing, so if it's not a whole number, then it will just be approximations. So this one's between -1 and -2, so that's -2, -3, -4, -5. So that'd be between -4 and -5 then for your other solution. And then that's your answer there. And then, so you're gonna work your way through a Google Doc or the drawings kind of like you did yesterday. So it's just that once you graph them, you'll say what your solutions are. Just make sure that all your terms are on the same side. If not, like this one was fine, but then this one, we had to add the 4 to start so that they were always already on the same side. And then you can sub in the -1, 0, and 1, and then see which way it's going to see what you should sub in next. And then you'll just figure out where it touches or crosses your x-axis. And let me know if you need help with this at all, though.